steady state gain equals to 2. Here we can write from the pole 0 plot the transfer function as this is s plus 1, steady state gain is k. Here s plus 2 whole square plus j1, this is 1 square. So k of s plus 1 divided by s square 4s plus 5. Here steady state gain means limit s tends to 0, g of s is equals to 2. That means k divided by 5 is equals to 2, which is k equals to 10. Hence we can write open loop transfer function as 10 into s plus 1 divided by s square plus 4s plus 5. Hence option C is correct. Question is, in the circuit shown below, each battery is of 12 volts and each resistance is 6 ohms. Then the current IA is. Here, from this node to this node, the potential is 12 volts. Here, the battery is given. So, this 12 volts potential which decides the current in this loop. So, if we apply KCL here, that is VA by 12 plus VA by 6, VA minus 12 by 12, which is equals to 0. Hence, if we take LCM as 12, VA plus 2VA plus VA minus 12 equals to 0. So, 4VA is equals to 12. VA is equals to 3 volts. Hence, IA is nothing but VA by 6, which is 3 by 6 is equals to 0.5 amps, which is option D is correct.
Commutation technique is employed in. Okay. Now, if you see here, AC voltage controller has line commutation. Class B commutation is nothing but current commutation. Okay. And Jones chopper is class D commutation. Okay, it is called as voltage commutation technique. If you see series inverter, this is of load commutation technique. So Morgan chopper is used current commutation, or you can say it as class B commutation technique. So option A is correct answer.
Is the standard deviation of Poisson distribution 2p of x equals to 1 equals to p of x equals to 2. Here, the Poisson distribution probability of x equals to r is m power r e power m e power minus m divided by r factorial. Here, 2 m power 1 e power minus 1 divided by 1 factorial is equals to m power 2 e power minus m divided by 2 factorial. So this m is nothing but this gets cancelled, m is equals to 4. Hence variance mean both are equals to 4. Hence standard deviation is equals to under root of variance, that is 2. Hence option D is correct.
Between phases of primary and secondary is, okay, let us take primary first. I will take the connection between A1 and A2 as A phase. Similarly, this is B, this one is C. Okay, here this is A, B, C respectively in primary and secondary. Okay, now primary is connected in delta fashion. Okay, let us take this is A2, B2, C2. Okay, A2 to B2. See here, this one is A2. From A2 to B2, we have B phase. Okay, from B2 to C2, we have C phase. Similarly, from C2 to A2, we have A phase. Okay, now this is the phase sequence. A, B, C in primary. Now we have to draw same way in secondary side also. Okay. See here at the bottom I have C phase, so I am taking C here. Okay. Now this is C2 winding. Okay. Let us take this one as neutral N. On secondary side we represented with short letters, so I am taking small n. If this is the C phase, okay, I want to maintain same phase sequence in star connected. The distance between, the displacement between these two should be 120 degrees. Similarly, 120 degrees. This is also 120 degrees. Since my phase sequence should be maintained same, now if I move like this, what is this one? This is A phase. This one is B phase. Now superimpose this secondary winding with respect to primary one. Okay, if you superimpose this one, let us take this as neutral N. Okay, now A is the connection like this. Okay, C is in parallel with primary C. So this is C and this one is small a, and B will be like this. Okay, this is B phase. Now, the displacement between these two phases is 30 degrees. Now, which one we have to choose? He has given option A as plus 30, option B as minus 30, C as 210 degrees, D as 150 degrees. Okay. Now, the displacement between this A2 and capital A2 is 30 degrees. Okay. When you subtract this one, it will go to A2. So, my answer is minus 30 degrees is the phase displacement between primary and secondary. So option B is correct. Shunt generator is shown in figure has critical resistance and shunt field resistance as 800 ohms and 300 ohms respectively. So RC he has given as 800 ohms, RSH he has given as 300 ohms. Okay. So now when the machine will build up voltage, okay, when RC is equal to RSH, or you can write when RSH is equal to RC. Okay. But in question, he asked here if shunt field resistance, that is shunt field resistance, is varied from 600 ohms, 500 ohms, 400 ohms. Okay. If we varied shunt field resistance like this, then generator can build up voltage fastly at. Okay, see here. Now we know shunt field resistance RSS is equal to 300 ohm. Now what is total shunt resistance? RSS plus rheostat resistance. Okay, so this is 300 plus. First he varied at 600. This is equal to 900 ohms. So RC is greater than, RC is less than RSH T1. Okay. Now what is RSH total resistance in second time? This is 300 plus. Next he varied to 500 ohms. Okay. So this is 800. So I can write RC is equal to RSH T2. Now what about third one? RSH T3 is equal to 300 plus 400, this is equal to 700 ohms. Okay, that means critical resistance is less than shunt field resistance, total resistance at position 3. So the generator will build up voltage fastly at. Okay, when critical resistance is less than shunt field resistance, voltage will build up fastly. Okay, so answer is at position 3, that is option A, 400 ohms.